Hey guys, it's Sunny D here from the Discord, from Heavy Recoil Club, I think it is. Today's video, we're going to be discussing the RDX Boss Unit from RDX Technologies, if I remember correctly the name of the company. So, I'm going to be reviewing my thoughts on it, my experience with it so far. I've owned the unit for about 4 months at this point. According to the firmware, I'm around 12 to 14,000 rounds fired on the unit itself. So I'm going to be reviewing my thoughts on it, how I wired it up on my gas blowback rifle, and explain my circuitry of how I did it. So that way, if anyone else is crazy enough to run a RDX Boss unit on a gas blowback, at least they'll know how. So first we'll start with the review of my unit here on this gun. Hopefully this gun fits here in the frame. This thing's huge. So, the long story short, my review of this unit, extremely positive. I think everyone should own one. Again, I don't think so everyone has the same thoughts on that, but I personally think it's the best thing that ever happened to airsoft. But everyone's entitled to their own opinion. So far, I've owned the thing for 4 months at this point, mainly playing outdoor fields since February this year, and thing works flawlessly. I had a firmware update not more of a firmware update, but there was an adjustment made to the gas setting here to increase the amount of gas per tick here from the default, because it was defaulted in New Zealand and they have different weather. So spark time was also increased. But that was the only thing that ever got changed on this thing. And the thing runs like a champ. There's so many smart little settings on the sucker that prevent you from doing things it doesn't want to do, prevent it from damaging itself, all that sort. Like for example, if the cylinder doesn't fire or it gets obstructed, like you fire and your finger's here and it gets smashed, and it's not fully closed, the thing won't fire again. So instead of igniting the spark here, you guys can barely see it. Instead of igniting and shocking you because your finger was somewhere where it wasn't supposed to, there's a magnet on the end of the sleeve there, and I assume a Hall effect sensor here, that tells the unit if the cylinder is closed. If it's not closed, the thing alarms out, and it won't fire until you reset it and press a button. My only gripe with it so far, the only gripe, is, as you can see, this handguard here is not the original. I have the original right here. As you can see, it's not black anymore. I've repainted this. The white here you see is the primer. I painted it with black and then matte coated it. The green you see there, that's what it was. That's the plastic. I think this is like a resin. It's green and then painted. It keeps wearing down, and I'm using gloves, like normal gloves. That is the only issue I ran into with this handguard. So, RDX Technologies posted STEP and STL files for their handguard on their website for anyone to download for free. That's what I did, 3D printed my own out of ABS glass fiber. So far, this thing seems to hold up. We're going to find out this weekend if it does survive, but so far it seems to. So, yeah, basically, my review of this thing, solid thing. It's a solid unit. It's a bit pricey because it's an experimental product, and I get that, coming from someone who has a background in manufacturing and machining. There's a lot of safeties built into this thing on the circuit board here that prevent you from doing things it doesn't want to do, on all that sort, the signal and all that. But my guess on why this thing costs $775, at least what I purchased it for, it's probably a little bit more now, is this is a lot of freaking custom machined pieces. It's like it's the whole chassis here, besides the hand grip, is aluminum. It's really well finished aluminum too. Like super smooth finish. There's no defects in the anodizing here. And it's pretty durable too, because I beat the shit out of this thing. The upper here, that's mounted, aluminum. The Picatinny rail mount here, aluminum. The whole thing is aluminum. So that is my guess why this thing costs so much. Is just all the tool and die of making the entire thing out of metal. Especially nice quality metal and getting it finished correctly. Because this is some really high quality anodizing. That's why this thing costs so much. That, and they're making super low quantities. But in my opinion, I've only had the thing for 4 months. Worth every single dollar. I enjoy this thing a lot. So that's the short of why I think everyone should buy a Boss unit. I don't recommend it for anything other than an outdoor place, and I would check with your field owner, because there's a chance that the neighbors will eventually not like the field owner, and he will tell you not to run it anymore. So depending on your field, I would check with that. I'm here in the United States. I bought my Boss unit from Zulu Outdoors. I think they're out of sale right now as of June 20th, but they're the main distributor here in the States, and their field allows it. I highly recommend going to Zulu Outdoors in New York. Awesome field, but solid unit. It's just awesome, and the customer support for this thing is pretty solid too. So it's my review of the Boss unit. As for sound, I know Zulu's doing some videos comparing sound levels. This is, I would say roughly, it sounds around 110 to 120 decibels. Some would argue it's quieter than a 22 going off. Not much, but it is noticeably quieter. Depending on where you are, you may get sound reflection, so it may be a higher decimal. But standing next to it going off without hearing protection, it doesn't immediately ring your ears unless you have sensitive hearing, but it's not comfortable. So you have to wear hearing protection when you're running the gun. And in general, you should be wearing some sort of hearing protection in airsoft, just because the grenades and stuff, but recommended wearing hearing protection. Now, as for how this thing is running on a gas blowback, that's the other interesting part here. So this is the KWA Basada. This is my baby here that I've been not letting die. So the Boss unit. So for power, you can't, what was it? I think the rated input is somewhere between 7 volts DC to 13, 14. I know you can't power the thing with a 1S LiPo, and I know you can't use a 4S LiPo. I think I was told that there's circuitry in here. If you plug a battery that's not gonna like, the Boss unit will not turn on until you plug a battery that it does like. Don't quote me on that. Do not try that. The spec sheet on their website, I would recommend going through that. But it's somewhere between 7 to like 14. I know I run a 3S LiPo, so 12 volts or 11.1 is what everyone calls it. I had good results with that. I know some people run 7.6 and they've had good results with that. So that's power requirement. As for wiring, this is the part that everyone gets all stuck with. Let me go grab my wiring on this here. So in the box, you will get the Boss unit. If you buy from Zulu, you get the Boss unit and 2 wiring harnesses. So this is my second one here I didn't use. So it's just a plug that plugs in the back here. As you can see, the little wire, it just plugs in right in the back of the unit, right there. And it's 3 wires. So super simple. Red, positive battery. Black, the ground from the battery. Make sure your battery's within the range they specify, otherwise the thing won't turn on, it may break it. That powers the unit up. To give the unit the signal, the white wire has to be pulled down to ground. Does it? Yes. Yeah. So pull this wire up to the positive terminal of the battery to keep it from firing. When you want to fire, you need to switch this wire to ground, or the negative of the battery. That gives the Boss unit the signal to fire. Super simple. It's 3 wires. If you know how to tech on your gun, or you know somebody who does, it's probably not that hard to do it on an HPA engine with one of the accessory boards or accessory slots, or AG on the trigger contacts. But I don't have any of those because this is a gas blowback. So to start with, the battery, I run it external here. As you see, that blue cable comes down the hand grip with the airline and the battery cable. I run an external battery, so I can use some hobby 3-cell batteries. So that's how I power the Boss unit. As for giving it a signal, as you can see, my barrel is wrapped in paracord. That actually has a reason. The power from the battery plus the signal wire comes up the barrel here. It goes into my mock suppressor, in which I have circuitry to optically sense a BB every time it flies by to give the Boss unit a signal. I know this looks like a lot. Not all of this circuitry you're seeing here is actually for the Boss unit. I am experimenting with making my own Smoky Wolf as the LED ring you can see on the front. So, long story short, there's an optical sensor that sees the BB fly by. It's always on. When the BB flies by, it breaks the beam, gives a ground output from the optical transistor on the sensor. That goes to a Darlington pair of transistors here. One of them switches from the 5-volt logic, because the optical sensor is 5 volts down here, to 12-volt logic, aka what the Boss unit's signal pin is based on, and the other one there inverts the signal. Because this is always on from the optical sensor until BB breaks the beam, that would mean the Boss unit would be always firing until the BB breaks the beam. So that's what that extra transistor for. It's an inverter. This, and in the other part of the circuit here, is a 5-volt linear regulator that turns the battery voltage to 5 volts, which then powers the optical sensor. Everything else you see here in the middle, that's for the Smoky Wolf. I wouldn't worry about that. I have a Venn diagram. Oh, not Venn diagram. Why am I saying Venn diagram? Circuit diagram here. That explains it roughly, as you can see. So we got battery voltage coming in, goes to a 5-volt regulator. So it turns it down from battery volts, which is I use 3S LiPos, so 11.1. It's roughly around 12 volts. That turns it down to a nice 5 volts. The optical sensor uses that. Goes into the 5-volt to 12-volt transistor pair, which then goes to the RDX switch. And in that 5-volt to 12-volt transistor is the inverter for the logic. So, as we go to the actual Venn diagram here, not Venn diagram, why am I saying Venn diagram? The actual circuit diagram, as you'll see up here, 5-volt linear regulator and its opposing circuitry, diodes, capacitors for each side. That comes from the battery, VDC, the 12-volt positive comes in. You get 5 volts out, which goes to the optical sensor. And you got the ground here, which then goes to the optical sensor. That powers the infrared LED and gives the optical transistor what it needs to switch. From there, it switches the 2N5088 NPN transistor, which converts from 5-volt logic of the optical transistor here from the sensor to the battery voltage, or 12 volts. So it takes 12 volts and it goes into the next transistor. So then that goes into a 20 ohm resistor, which then powers the next transistor, which then switches the RDX signal wire, the white wire, and it pulls it down to ground every time it receives a signal. That is all you need to run this sucker. As for part numbers here, the optical sensor I have used is the HY810A optical sensor. 5-volt linear regulators, you can find them, but the one I use is the L7805CV-HXY. Transistor for the 5-volt to 12-volt logic, I use a 2N5088 NPN transistor, and I drive a 100 ohm resistor for a current to power that. From there, that transistor drives a 20 ohm resistor to power, or that we call, to switch the gate with the current of a 2N4401 transistor. This is all, that final transistor has a 10K pull up to the battery positive. The optical sensor here has a 100 ohm resistor from the 5-volt to limit current going into the infrared LED, and then the other part is connected straight to ground. The optical transistor here on the other part of the sensor has a 10K pull down to prevent a floating input. And that's pretty much it. The 5-volt linear regulator, there's a 1N4001 diode that goes from the 5-volt input and allows current to flow back into the 12-volt DC input. And then there's capacitors on both sides. If I remember correctly, there's no specifics on what capacitors to use. I just use what was the data sheet. So this is the circuitry. Again, this is all prototype. Eventually, I'm going to use integrated electronics, aka SMD or surface mount devices, to make this smaller. Haven't got to it, it's still experimental. That's how I tell my gas blowback, hey, a BB has been shot, because I don't have trigger contacts. Just wanted to put this circuit diagram out there for anyone to use. Kind of want to see what anyone else comes up with. I know some people use a micro switch down here next to the trigger. That's great and all, but you run into issues with water messing with the micro switch. And also, depending on how you're pulling the micro switch, you may get more than one fire. Also, it's kind of clunky, in my opinion. And this way, this is my personal opinion, not necessary. I like putting a suppressor on the gun because it's more realistic to the sound profile. This RDX unit is not as loud as a real rifle, unsuppressed, but it's possible to pass it off as like, yeah, if it's a suppressed rifle, it'll probably make sense. Personal grievance, nothing important. So that's how I managed to make my gas blowback run a Boss unit without trigger contacts or using a micro switch. RDX Technologies heavily advises from anyone running a pure gas-fed gas blowback rifle with the RDX Boss unit, because there is a concern that using the gas from the magazines here can catch on fire from the barrel or from the breech and cause an ignition all the way down to the gas into the magazine. That is the concern. I don't recommend it. Don't run your gas blowback with green gas and a Boss unit. CO2 is fine, HPA is fine, which is what I'm using. Don't use green gas. There was an incident at Zulu that someone had their face catch on fire, very light burns, but singed the hair on their face because they had a MAP gas filled magazine on a gas blowback. It was the one time they had a failure, and I think it had to do with 2 BBs getting stuck in the breech, causing a malfunction, ejecting all the gas out of the magazine, which then caught on fire in his face. Again, the injury was just some singed hairs on his face, no real burns, but that's why you shouldn't really run it on a green gas gun. At least my experience, it's probably, if you're running a short barrel and your barrel ends right above the front firing cylinder, I wouldn't recommend it. On my gun, because my inner barrel is all the way up to the suppressor, it's possible it's fine. Not recommended. Don't do it. It's just not worth it. Just run CO2 mags or HBA. It's the last thing you want to deal with is a pure consequence for having a malfunction. But that's it, folks. That's how I run my gun, my gas blowback with the Boss Unit. If you got questions on why I did certain things the way I did, or you want to replicate my project, let me know down in the comments. I gotta post the files eventually for the suppressor. Still working on them. I might actually make the suppressor smaller eventually once I finalize that circuit and make it super small. I can probably make the suppressor way thinner. But until then, keep playing, man. It's about the sport. So until next time, folks, let me know if you have any questions, comments, concerns, or what you want to see next. Peace out.